So today we're going to talk about graphing transformations of the tangent, cotangent, secant, and cosecant graphs. Okay, so for our first example, we are going to graph a transformation of the tangent function, and then we're going to find the domain and range. So the first thing that I always do that is rewrite my equation so that I can see what my A, B, C, and D are. Okay, so right away I can see a lot is going on here. I'm going to have a vertical stretch. I'm going to have a horizontal shrink. I'm going to have a phase shift of pi over 4, and I'm going to have a vertical shift up 1. Couple things that are different than tangent from sine and cosine. First of all, when you find your period, this time it's pi over b. And so you need to remember with tan that our period is pi instead of 2 pi. So my b here was 4. So my period, I should repeat every pi over 4 units. Okay, my step is still a quarter of my period, so it became pi over 16. And the other thing that's different with tangent, instead of having our first, a lot of times in our tables with sine and cosine, we changed our first value to negative c. Okay, you can change your 0 value to negative c. Okay, but a lot of times what I do is I know that my original x is now 4x minus pi, which is just coming from here. I solve for x, and I look, my original start value in my table right here was negative pi over 2. So I plug that in for my x, and I see that my new start value is pi over 8. Okay, so I did this in my table, pi over 8. The reason I wrote this in terms of sixteenths is because that's my step. Okay, so I just did that to make life a little easier for myself. So I went up by pi over 16. I simplified whenever I could. And then I did the same transformation thing as we did before. My y is now going to be 3 times my original y plus 1. Anytime I multiply something that's undefined by a number, I still get undefined. Okay, so I came back and I plotted my two asymptotes. Oops, sorry, this would be my first one, pi over 8 and 3 pi over 8. And I plotted my points in between. And then I just continued that pattern. And you always want to make sure, I didn't put it in the directions, but generally you're going to be asked to graph at least 2 periods. So on my graph, I have 4 nice periods. Okay, again, you want to be consistent with your tick marks. Okay, you can't start at pi over 8 and then have this be 3 pi over 8 and then have this be like 5 pi over 8. Okay, you need to be very consistent about your spacing on your graphs, both in the x direction and in the y direction. So this is something new that we need to talk about, the domain. Anywhere there is an asymptote, okay, this is the same as with our rational functions, we need to exclude those values from the domain. So that's why I have x cannot be, it cannot equal. I always start with my first positive value that has an asymptote. In this case, it was at pi over 8. And then I look at what the difference is until my next asymptote. And I apologize on mine, it's a mistake. This should be pi over 4, okay? Because I'm going 1 period until my next asymptote, and that is pi over 4 units. Okay, but look, it's happening after 1 pi over 4 cycle, but then it's happening over another pi over 4 cycle. So that's why I want to multiply it by n, where n is an integer. I discussed this in my notes earlier in another section. Okay, and also if I subtracted a pi over 4, okay, if I let n be negative 1, I would end up at this asymptote. Okay, so that's why it's an integer. It can be positive or negative values. There are many ways you can write this. You could also start, this is negative pi over 8, right? So you could say that x cannot be negative pi over 8 plus pi over 4n. Okay, there are an infinite way to write this as long as you're generating the same list. Okay, and then hopefully you can see for our range, okay, it's all real numbers. Our next graph is of the secant function. Okay, again, I always try to look at my A, my B, my C, and my D. So I am seeing that I am going to have a vertical shrink by a factor of 1/2. Since my B is less than 1, that means my graph is going to be stretched horizontally. I have no phase shift, and I should move my graph up by 3 units. Okay, so again, my initial values, okay, these are what we derived yesterday. So I put those into my table. I know that for my secant and cosecant graphs, those are related to the sine and cosine, or cosine and sine, I had them backwards. So my period is 2 pi. I divide by b. My new period is 6 pi. Okay, so every 6 pi units, I should see a down cycle and an up cycle. Okay, my step is going to be a quarter of that period, so it's going to be 3 pi over 2. My original x is now x over 3. When I solve for x, I get x equals 3 times my original x. My first x value, my start value here was negative pi over 2. When I multiply that by 3, I get that my new start value is negative 3 pi over 2. Okay, and I just took my step and I added 3 pi over 2. So 3 pi over 2 plus 3 pi over 2 was my 6 pi over 2. I simplified that to 3 pi. I added another 3 pi over 2 to 6 pi over 2 to get 9 pi over 2. Okay, I think the vertical transformations are pretty easy for people. Again, you need to remember anytime you multiply something by something that's undefined, it stays undefined. When you are graphing the secant and cosecant graph, you just need to remember that if you are so when I plotted 3.5, so at 0 I plotted 3.5, and at 3 pi I plotted 2.5. When you look at those, you need to know just that the higher number you're going to make a cup going up, and the lower number you're going to make a cup going down. These look like parabolas, but they're not parabolas. Okay, if you do it on a graphing calculator like Desmos, you can see they don't have a parabola shape. These ones have a much more cup shape. Okay, so now our domain. Again, anytime we have an asymptote, we are going to be excluding values. Okay, so I say that x cannot be my first positive asymptote, which is 3 pi over 2. I look, my next asymptote is 9 pi over 2. I realize the difference between there is 6 pi over 2. 6 pi over 2 simplifies to 3 pi. Okay, so if I go 3 pi units, I'm at an asymptote. If I go another 3 pi units, okay, that's 6 pi over 2, I'm at my next asymptote. Okay, so I can see that's the pattern. And if I go 3 pi in the negative direction, okay, this distance is 6 pi over 2, which is 3 pi. So again, this notation is important. You're saying that n is an integer. My range here, hopefully you can see there's some space in the middle of the graph, right, that doesn't have any values. So I have values from negative infinity all the way up to 2.5, including 2.5. And then I don't have any values until I hit 3.5, including 3.5. And then my graph goes all the way up to infinity. So there's my range there. Okay, for our last graph, we have a cosecant function. So again, here my A is negative 2, so that means that I'm going to have a reflection over the x-axis, and I'm also going to have, I'm going to have a vertical reflection, and I'm also going to have a vertical stretch. My B is 1, so that means I'm not changing my period. I'm going to have a phase shift because C is pi over 2. And I'm going to have a vertical, I'm going to move up vertically 4 units. Okay, so again, I start with my XO and YO from the tables that we determined yesterday. My period is still going to stay 2 pi, okay, because my B was 1. So my step is going to be pi over 2. Again, my original X is now X plus pi over 2. I solve for X, I get my original X minus pi over 2. Okay, so my original start was 0, so 0 minus pi over 2 is negative pi over 2. My step says that I'm going up by pi over 2, so negative pi over 2 plus pi over 2 is 0. 0 plus pi over 2 is pi over 2, right? We keep going, we get pi and 3 pi over 2. Again, same thing as before, okay? If you're multiplying by undefined, you still get something undefined. Okay, and my y value here, I was just doing negative 2 times my original y plus 4. So again, sometimes because of this reflection, it gets confusing to people. But all I'm going to look at is I am going to plug in 0, 2. So I'm going to plot that point. And then I'm going to plot pi 6. And instead of worrying about other values, I'm just going to remember that if I'm the low number, I'm making a cup shape down there. And if I'm at a high number, I'm making a cup shape this way. Okay, so again, my domain, I have asymptotes, so I am excluding numbers. Okay, I go to my first positive asymptote. I say X cannot be pi over 2. And then I look, what's the difference to my next asymptote? 3 pi over 2 minus pi over 2 is 2 pi over 2, which simplifies to pi. Okay, and if I go another pi units, another 2 pi over 2, I end up at 5 pi over 2, and again, that's an asymptote. If I add another 2 pi over 2, I end up at 7 pi over 2. That's another asymptote. Okay, also, if I'm at pi over 2 and I subtract 2 pi over 2, I'm at negative pi over 2. Okay, in our range, hopefully you see you start at negative infinity, you go up to 2, you include 2, then there's a break, there are no points in here, and you start at 6, including 6, and go up to infinity. Okay, so real quick, I talked about how your domain can look different. So let's say I say X cannot be pi over 2 plus pi n, where n is an integer. Okay, this is the list we found above. Pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. And it's going to keep going on, right, as the numbers get bigger. But then it's also, we talked about how it's going to be negative pi over 2. Okay, it's going to be, if we subtract, it's going to be negative 3 pi over 2. And it's going to keep going in the right direction. Okay, sorry if you couldn't see those. So let's say instead a student looked and said, okay, well, I see that X cannot be, and they start with this number, negative pi over 2. Plus, they also notice it happens again at pi n, where n is an element of the integers. Well, let's see what this list looks like. We're going to have negative pi over 2. Then if we add, this is the same as adding 2 pi over 2, right? We're going to be at pi over 2. Then we're going to be at 3 pi over 2. Then we're going to be at 5 pi over 2. Okay, and it's going to keep going like that. And if we subtracted that amount, we're going to get negative 3 pi over 2. And it's going to continue that way. What do you notice about these two lists? They're exactly the same. Okay, so there are multiple ways to write these lists. I don't mind which one you use, I'm just telling you that by convention, I generally look for my first positive one. Okay, because it's pretty easy